Hello everyone. This video is on Unit 4 Lesson 7, Linear, Quadratic, and Exponential Models. You should be familiar with all three of these things by now, but we're going to talk mostly about how to differentiate between the three based on a table. I'm only going to show tables in this lesson, by the way. Just remember that you can make a table out of any list of coordinate points. So if I had like 1, 1, 2, 4, I would be able to make x, y, put in 1, 1, 2, 4, and so on and so forth. Just remember that the first number is always the x and the second number is always the y. And then I would recommend using tables just because it's a little bit easier to see the patterns in that case. But I just realized that, and that's why I threw that information out there. So I do have this resource right here, which, if I remember, I will also put in the notes of this video. And this flowchart will help you to have a method for determining what the different if a specific pattern matches the different types of models. So if something is linear, quadratic, or exponential. The order that I recommend looking at them is look for exponential first. So for exponential, you want to look for repeated multiplication for the y values. If it does have repeated multiplication, it is an exponential relationship. If it does not, then you want to look for repeated addition. This is the one that most students know. So if you see repeated addition, then it is a linear relationship. And now this one is the tricky one. This one says check for repeated addition and your y value differences in the previous step. I'm going to show you that in a second. It's confusing. Not as confusing when it comes to like the calculations, but the wording is confusing. So if this thing is true, which you probably don't know what that means at all, we'll talk about that in a second, but if that is true, then it's quadratic, and if not, then it is none of those three. So let's look at some examples. So according to our flowchart, the first thing that I want to check is repeated multiplication. So then I have to figure out, so if I look at all my x's, I'm going up by 1, which is great, and that means I don't have to worry about that part. And then for my y values, well, what do I multiply by 5 to get 3? Negative 5 divided by negative 3 equals 1.1666, so yeah, I'll just drag that right over there. And then I'm going to check to go from 3 to negative 1. So from negative 1 divided by, wait, did I do that right? No, I mixed it up. Should be negative 3 divided by negative 5 to figure out what times negative 5 is equal to negative 3. Yes, correct. Now I've got it. 0.6. All right. And then to figure out what times negative 3 gives you negative 1. Negative 1 divided by negative 3 is equal to not the same. Okay, so because these two things are not the same, I'm not multiplying each y value by the same number to get the next y value. So that means it is not an exponential model. So I'm going to just put not, and then a little caret, because that means exponential to me. It means an exponent. That's what that means, not exponential, because it doesn't have a common difference. So then next, according to my flowchart, no, you go to the blue part, check for repeated addition for the y values. So then if I look for repeated addition, this one I don't really have to do calculations, like use a calculator for. Negative 5 to negative 3, I'm adding 2. Now let's change colors there. I'm adding 2 to get from negative 5 to negative 3, and then I'm adding 2 again to get from negative 3 to negative 1, and then adding 2 again, adding 2 again. So I do have repeated addition. I'm adding 2 to each y value to get the next y value, so this means it is linear. So this is a linear function, or a linear model. All right, so we got that one checked off, and we don't even have to do the complicated one at the end. So this next one, let's look at this. So first I'm going to, according to my flowchart, I'm not going to scroll up, but I want to see if I have repeated multiplication. So if I, well, first of all, this one's going to be really fast. 1.5 divided by 0 is not going to work. Your calculator might tell you undefined or can't do it. Might just say can't do it. But you can't multiply anything times 0 and get anything other than 0. So you can't divide by 0. So it's not going to be exponential. I'll just write that. And then if you looked at the other ones, you're not multiplying each one by the same number to get the next one anyway. So you could also check the other ones. But even just that first one, I know that it's not repeated multiplication because if I had repeated multiplication and started with a 0, then the rest of them are all going to be zeros. So next, we want to look for repeated addition. So from 0 to 1.5, that's going to be plus 1.5. From 1.5 to 6 is plus 4.5? Yeah, 4.5. My mental math is way off today. All right, plus 4.5. So these are already not the same, but I'm going to continue for a reason. Let's see. 13.5 minus 6 is 7.5. Where did my mouse go? There it is. 7.5. And then from 13.5 to 24, 24 minus 13.5 is equal to 10.5. And I've lost my mouse again. This color does not show up well. Okay, plus 10.5. All right. So you do need, even at this point, if you know it's an exponential, you do need to do all of the linear, like, common differences, because then we're going to look for the common differences of the difference. So, you know, we figured out all of these numbers. That's what we're adding to each y value to get the next y value. But then we're going to look at the differences of these numbers and then see if there's a pattern there. So from 1.5 to 4.5, I'm adding 3. From 4.5 to 7.5, I'm adding 3. And then from 7.5 to 10.5, I'm adding 3. So these are all the same. So these are the same second differences. I figure out what I'm adding every time, and then I figure out the pattern of what I'm adding every time. So these are the second differences, and because they're all the same, that is a yes for this one. Check for repeated addition for your y value differences in the previous step. So I found that we were adding 3 for all of those values, so it is a quadratic relationship. So put a little check. This is quadratic. All right. And then finally, this last one, we had a linear and a quadratic, so you might be able to guess this one is exponential. So if I divide 2 divided by 5 is equal to 0.4. 0.8 divided by 0.2 is equal to, nope, 2, not 0.2. Yep, 0.4. And then 0.32 divided by 0.8 is equal to 0.4, so on and so forth. If you divide each of those values by the previous value, you will see that you're multiplying each y value by 0.4 to get the next one. So this would be exponential. Now, I do want to show you something that is pretty neat. If you remember, especially if you were in my class first semester, we showed this Desmos formula, the linear formula, and we checked to see if it was a linear function. So I'm going to show you that. And let's see how I want to do that. I want to do to the left. And I want this one. I want that one to the right. Okay. So what you can do is actually I'm just going to copy and paste them exactly as they are. Y1, oh, that didn't work. So if you do like Y and then you type 1, it'll do a little subscript there, and that's what you want. All right. Now, this is not referencing anything because I don't have any tables in there right now. So for right now, I'm just going to put the formulas in there, and then I'm going to put the table in there. And the table is going to have an X1 and a Y1, and that is what is going to tell us all the information that we need. So for right now, I'm just putting all three of the formulas in there. And then we're going to see in a second what happens. All right. I'm going to click on plus, and then I'm going to click on table, and I'm going to drag it to the top, hopefully. Now, because I've typed in other things, this automatically populated a table that has x to the fourth and y to the fourth. I do not want x to the fourth and y to the fourth because all of my formulas are referencing x1 and y1. So I want x1 and y1. So I'm going to change that, just delete the 4 and put in x1 and y1. So this first one, I'm going to type it in. I'm just going to do the first 3. Because you're going to see... Well, I guess I'll do all of them. So I'm just putting in this first table, 0, 1, 2, 3, 4, and then negative 5, 3, negative 1. Just putting that table in exactly as it is. I was going to try to cut down on some time, but I don't think that's going to be helpful. All right, so I put that all in there, and now what all of these are doing is they're trying to create a... they're trying to create a model for it. Now, what I just noticed is that this last one, this quadratic, is saying that r squared is equal to 1, r is equal to 1. So that's saying it's an exact match. However, it's saying that a is equal to 0. So basically what they're doing is getting rid of that first term and then having b x1 plus c. So we already said that this one was linear. So if you see this blue graph here that's trying to make it an exponential, it doesn't quite work. It's not going through the points. This one cheats by making that one equal to 0. I did not anticipate that. But this one tells you that our r is equal to 1. R is the correlation coefficient, and that tells you how well your line matches the data. If it is exactly equal to 1 or negative 1, it is a linear function. Now, the r squareds work very similarly. So if r squared is equal to 1, you would assume that it's that type of function. However, like I said, this one is cheating because it's saying a is equal to 0. You can't have that because then it's not a quadratic. It's a linear because you don't have that x squared term. So that's another way to check. And let's see. I will just go ahead. 2 minutes left. I can do it. All right, so let's put in the second one. That one is 0, 1.5, 6, 13.5, and 24. All right, this is pretty cool. So I put in all of those data points, and you can see it tried to model all 3 of them. If I look at my y1 approximately equal to mx1 plus b, that's my linear function. It's not linear because the r is not equal to 1. It's pretty close. It's not. It's pretty close to positive 1, so I'd say that's a strong positive correlation. However, it's not equal to 1, so it's not exactly. This one, we don't have an r, but we do have an r squared, which again, pretty close, but not exact. And finally, this quadratic is r squared is equal to 1, and the a is 1.5. So as long as a is not equal to 0 and r squared is equal to 1, that means it is quadratic. So that is just another strategy that you can use. I'm running out of time, so I can't do the exponential one, but you can try it on your own. So just another resource and another strategy to use. If you have any questions, let us know, and I hope this helps you with your lesson.